Okay, guys, so the scanner has a magnification of 4 times. How about for the LPO? That is 10 times. Okay, good. HPO, that is 40 times. And the OIO, it has 100 times magnification. So to get the total magnification, you compute, you multiply the magnification of the objective by the magnification of the eyepiece. Okay? So, for example, what is the total magnification of um, an object that was magnified using the HPO? That is 400, because the HPO, it has a magnification of 40 and the eyepiece has 10, so 40 times 10, that is 400 times. Okay, so 400 total magnification for the example that I have given you. Okay, so resolution. The resolution is the ability of the lens to delineate detail in a specimen. Okay, so that is determined by the two factors, the numerical aperture and the wavelength. Okay, so we will not confuse for this one already. On the other hand, the resolving power, also known as the limit resolution, that is the ability of a microscope lens or optical system to produce separate images of closely positioned objects. Okay? Kumbaga, it will resolve the problem about two different objects that are close together so that the microscope or the viewer can still differentiate the two objects that are near each other. Okay, so for light microscope, that is the resolving power is 0.2. Okay, and for electron microscope, that is for 0.01 or 10 nanometer micrometer. Okay, so micrometer and nanometer. So, working distance, it refers to the depth of space between the top surface of the specimen slide and the front surface of the objective lens. So, when we say working distance, for example, you have here a slide, okay? So, the working distance is the distance between the top part of the slide and the objective that is present here. Okay, so that is for the working distance. Okay, so I already discussed, I think, the differences between the four main objectives of a compound microscope. So these are the parts of the objective. Okay, so for example, here you have the slide. Okay, and that is the cover glass. So the space between the objective, okay, and the glass slide, or here in this case, the cover slip, that is termed as the working distance. Okay, so those are also the other parts of the objective. And again, it has color coding of the different objective. Okay, let's review. Okay, what is the color for HPO? That is blue. How about for scanner? Red. LPO, yellow. And for OIO, that is white. Okay, so we have here, guys, the types of lens, the low power, we will not include here a discussion on the scanner because in reality, we don't use it in the laboratory, okay? We almost proceed right immediately to the LPO, okay? So take note, guys, that the higher the numerical aperture, so here, the higher the numerical aperture, the better the light gathering capability of the lens will be. Okay? So thus yielding greater resolving power. Okay?